matrices. As I said, everything that you do with 2 by 2, we are going to apply it to 3 by 3 matrices, right? So I just want to go over the 2 by 2 rules. Some of the things that you have to be able to do is to multiply matrices. You have to be able to find the determinant, find the inverse. All right, so we're taking a look at matrices. Right, so as I said, we're starting with a review of 2 by 2, right? So let's start with a matrix. Let's start with the matrix A, B, C, E. Right? And let's just run over a few things quickly. So first thing we need to remember is how to find the determinant of A. The determinant of A is written 2 lines around the A. And that'll be A by D minus B by C. Right? That's how you find the determinant of A, right? Just a quick rule, if the determinant is equal to 0, what type of matrix is that? Am I do it? If the determinant is 0, then the matrix is singular. And then how do we find inverse? So to find the inverse is 1 over the determinant of A, 1 over the determinant by something called the adjoint of A. I know you didn't really pay attention to that word in Form 5, but now we gotta know what adjoint means. Right? Adjoint real simple. Right? Adjoint is where we switch around the A and the D, the positions of A and D, and change the signs of B and C. Right? That's the way you find the inverse. We have to do this, everything here for 3 by 3. All right? We have to do the same things for 3 by 3. And I also want to review how to multiply 2 matrices. What's going on? Also, right, copy it up. Let's take a look at how to multiply matrix. I think so, that's it.
That's where I good license.
Right? How do we multiply matrices? All we have to do is to multiply what? You don't know what to do? Multiply row by column. Row in matrix 1 by all the columns. Row by all the columns. All right? So you're multiplying the first row by third column. 2 by minus 1 is minus 2. 2 by minus 1 is minus 2. 1 by 3 is 3. Right? Then row by column again. 2 by 4 is 8. 1 by minus 2. Then you finish with the first row. All the columns, you're done with your first row here as well. Next, second row, first column, 5 by minus 1, 1 by 3. 5 by 4, 1 by minus 2. So you'll end up with 1, 6, minus 2, 18. Right? So whenever you're multiplying, you just simply multiplying row by column, row by column. Right? When you multiply the row by all the columns, you're done with that row. Second row now, to get your second row answers, row, column, row, column.
Dude,
Yeah.
last thing we do was the the differential equation.
Yeah, that was the end of module. That was the end of differential equation.
Alright,
So differential equations, and
yeah, let's talk about some of the stuff on the LMS. It kinda they have under sequences.
yeah,
in the
the wrong
LMS.
figures.
They had the wrong videos. They have 5 minutes. Yeah. The guy here today. Alright. Calculation I will see back. A little extra. I will go through the one through where you'll be. Yes. Yes.
Right, so again, just remember row by column, row by column, row by column, row by column. So these are the things that we need to remember from form 5. Right, so I'm just giving you one example just for you to practice it over, and then we move to 3 by 3. Right, so try this please. I'm giving you a matrix A, 1, 2, minus 1, 1, and I'm giving you a matrix B, 0, 1, minus 1, 0. I would like you for part 1, I would like you to find AB, and part 2, find the inverse of A. Right? Find AB and then find the inverse of A. Now start matrices here, just be going over like
What would the opposite do?
false. Just what I want to hear. Everybody, yeah, there's some people that just what I want to. They decide to come to class late, they'll come to class. Finish? Alright, so this is 2 by 2, and then I'll give you, oh, I'm gonna show you how solving simultaneous too. Because we're gonna solve simultaneous with 3 variables, matrix method. Right, so you should have AB by now. AB is 1, 2 minus 1, 1 by 0, 1 minus 1, 0. So when you multiply row by column, 0 minus 2, row by column, you'll get 1. Row by column, you'll get 0 minus 1. Row by column, you'll get minus 1. Anybody get it? Yeah? That's the AB, right? And then to find inverse, 1 over the determinant, so that's 1 minus minus 2, so I got 3. Switch around the 1 and the 1, change the signs here. I'll get that?
Yeah.
Yeah? That's the matrix. Right. Something I forgot to write down here. Anybody could tell me what would happen if I take A, right? And I multiply it by A inverse. What would I get? Right? If I take A inverse and multiply it by A, I will get the identity I. Because matrix multiplication not commutative. But this will give you I. All right, so make a note of that, right? Because it applies to 3 by 3 as well. Whenever you multiply A by A inverse, you'll get I. Any questions anywhere? Right, so I just going to do an example for you in solving simultaneous, right? I'm going to do a solving simultaneous example for you.
Hold on, she class, let them write class. And all right, then not do.
Okay, done quick. Anybody remember this up? Right, we have to use matrix method, right? And as the people who get now out of class from that and it's also like that. All right, so first step, write in matrix form. So you take the coefficients of all the values, 3, 2, 4, minus 2, and multiply it by xy. Right? 3, 2, 4, minus 2. And multiply it by the variables here. And make that equal to 5, 2. Right? Make it equal to 5, 2. And then from here, all we have to do is to find the inverse of this and multiply it by this. So xy is the inverse of this, which is 3 by minus 2 is minus 6. Minus 8, I got minus 14. Switch these two values around, change the signs here. Right? And then I'm going to multiply that by 5, 2. When I multiply that out, you'll end up with xy. Work it out fast, and I'm going to see if I'm about to multiply. Right? And so the answer is supposed to get 1, 1, right? Supposed to get. So leave the fraction on the outside. We don't really need the fraction as yet. Multiply row by column, minus 2 by 5, minus 2 by 4. Minus 4 by 5, 3 by 2, that's 6. Right? So you'll get 1 over minus 14 by minus 4 minus, and then you multiply, and I got 1, 1 as my answer. Okay? So this is a quick review on 2 by 2 matrices. Our focus is really on 3 by 3 matrices, right? So we're gonna start now with 3 by 3. Right, remember when you multiply, row by column. Minus 2 by 5, minus 2 by 4. You only have one column, so you're done. Next row by column, 3 by 2, and add them. Ready? So we're jumping into 3 by 3 now. Right? Everything we did here, we had to do it 3 by 3. We had to find the inverse, multiply, and right? Head up 3 by 3 matrices. First thing we're doing is to find the determinant. Right? You could also put it in the calculator and get the values, right? So you could all check it back. You have to put your calculator in matrix mode. Go watch that video, right? So we're focusing now on 3 by 3 matrices, right? So if I give you a matrix M, let's see, I want to show you how to label all that. I'll show you in 2 by 2, but I forgot. Right? How to label every single position. The first value, right? The first value in a matrix belongs to the first row and first column. That's okay? This value here next to it is in the first row, second column. And last one is what? First row, third column. Here, we have second row, first column, second row, second column, second row, third column. Right? So if you want to give a matrix a particular location, you could use these two values. Right? And here, third row, first column, third row, second column, third row, third column. It also gives you an idea how to multiply together. So we're going to take a look at how to find the determinant of M. Ready? It's pardon me. No, no, those are nothing. All right, ready? So watch here. Right? Once you follow one, you go to right? Just follow. You can eat and follow. Right? So watch this here. How do we get the determinant? You can use any rule. You can use any rule. I will show you for one of the rules. Right? To find the determinant, you take all the first values. So you take A11 and you take the sign that goes with A11. This is called a sign matrix. Very easy to remember. Plus, minus, plus, minus, plus, minus. That's okay? So you're taking this here. You might recognize the sign matrix from 2 by 2s. Remember, these two stay positive and these two negative. Anyway, no worry with that, right? So you're taking the value and its sign. A11 and the sign to go with it. Right? You're taking A12 and the sign to go with it. And you're taking A13 and the sign to go with it. Okay? Now for the tricky part, right? Each one of these values have something called a minor. Each one of them have a minor. We have to learn to find that minor, right? So to find the minor of A11, you have to cancel everything in the row A belongs to and the column A belongs to. So you see this here? This belongs to row 1, column 1. If I cancel everything here and everything here, what you left with? You're left with a 22, A23, A32, and A33. That's okay? So you're left with a 2 by 2 matrix that we can easily find the what? The determinant of. Are you okay with that? So the only thing here is to remember how to get this. This is called the minor of A11. This is called the minor of A12, minor of A13. Right? Since we're just practicing, help me get the minor A12 now. What would it be? Right? Cancel here and cancel here. So it will be 821, 823,
831 and 833.
831, and 833. What about A13? Cancel everything here and here.
821,
821, 822,
831 and 833.
831, and 833. Right? Might be kind of hard to see, but in this one, there is no row 1 and there is no column 3. Right? Everything else. Everybody okay with that? It can also be done using the second row. It can also be done using third row. Any row you want. That's okay? So it's a note that any column could be used as well. Right? But we don't really use columns, right? Any row. Any row of column can be used. Any row of column could be by using the first one. No, I'll show you what. But we have two options. But here, almost call it sorry. Sophia, but here. So we deliver 3 by 3 now, and you have to be able to find the determinant, right? That's like the magnitude of it. You can use any row you want. I am using the first row. So I'm using each of these values together with the sign that it goes with. So the first one goes with a plus, second with a minus, third with a plus. Right? And after I get that, I need to get something called the minor. To get the minor, you take A11 and you minus everything in the row and column it belongs to. So you kind of remove it imaginary. Right? And then what you're left with comes in here. And then you find the determinant. A by D minus B by C. And you will get a value. Right? This could also be done in calculator, so you can check your working. All right. As I said, you could do it for your second row and your third row. It don't matter. All right. How you just choose. All right. So tell me which row you can choose here. I'll give you an example. Let's try this here. Right. You tell me which row you're going to use it and why. Yeah, Faith. First one, nah, I wouldn't do that. Second one, nah, I wouldn't do that.
No, I think first one. First one.
Alright. Right? What you normally do, like if you want, it don't matter which row you choose, right? But I would choose a row with a 0 because that will be one less to work out. Right? And the reason why I wouldn't choose this one is because I still have a minus to work with. The reason I'll choose this one is because these still be positive and I have no negative to work with. Right? So try it for a minute. Find the determinant, but I don't want to use these. I will use it. Just to keep your answer right. You use your row 1. Use row 1 and find the determinant. Huh? Row 1, yeah, you're using row 1. I am using row 4. I mean 3.
4.
3. The row with 4. One. Take your time. Take your time when you're working out the Take your time when you're working out the minus, right? Where's the answer? So let's start here. Okay. If you are start up. Any answers? Try use the calculator as well, right? Use the calculator and see if we can get a value. Any answers? Minus 7. Positive 7. Positive 7. I'm going to do row 1 and row 3. Anybody got 7 online? Which Katrina was it?
Where the physics? But I cannot.
Don't answer again. You don't answer much later.
Oh, what's happening?
Yeah, you can set up like you in the go. Right? So I using the first row, right? And I'll do the next one after. So that's minus 1004 minus 32054 and then plus 7 by 2 minus 150. So when you work out here, I got minus 4. When I work out here, I got 8. When I work out here, I got 5. Right? I got 5 here. 0 minus 5. So this is minus 4 plus 35. This is minus 28, so that's 7. Sapphire, you okay with these values here? How? Right. So I using the first row. I using the sign matrix. So +1, -3, +7. Right? Now I'm going to get the minor of these values. To get the minor, I'm blocking off this and I'm blocking off this. And I'll get -1004. And then I find the determinant in here. -1/4, -4. 0/0 is 0. And then I do the same thing here and here. Watch it again. I go down to the next row. I go and use the last row. So the last row is plus minus plus again. So it will be +5. I can leave out here because it's 0. +4, +4.
So I got -5.
No, that will be +5.
Why +5?
Because this is 0 minus minus. A by B minus B by C. Right here. So I'm going with 5, right? So I'm canceling the row and column it belongs to. 3, 7 minus 1, 0. I'm leaving out this 0 because it don't make sense, right? I'm going with 4 now. Cancel here and here. 1, 3, 2 minus 1. Right?
Yeah.
And now I'm gonna work this out. 3 by 0 is 0. 7 by -1 is minus, so that becomes +7. That is minus, right? Same thing here. -1, -2 by 3 is 6. So this becomes 35. This becomes 20. That's okay. That's how you find the terminal. Right, for homework, you can try using a column as well, right? It don't matter. Just use the sign matrix. Let's try next one now.
Oh.
I will put it two lines green that I find it permanent.
Right.
I will find the determinant of number 2 and then number 3, I do the reverse. I told you the determinant is 0. You have to find first.
I don't see them. I was. Jonathan.
Daniel, finish.
It's very. Thanks. I agree. Okay. Yeah, you know.
What y'all got for number two? How much? Minus 24. What's all you got? 12. You almost there. Divide by minus 2 and still up.
Let's do that song.
Huh? Yeah, 6. Multiply by 2 and still up. That's not how you say that. I can't do that now. But try the next one too. Try the next one, right? The determinant is 0. So you're working backwards. They told you what the determinant is. Using the sign matrix to get the using the sign matrix to get the value in front of using the sign matrix to get the value in front of here. Right? So when the first one saying that this is always plus, this is minus, this is plus. Right? So I would write it like this: plus by its minor. I'll find the minor that's now. Minus 3 because it's minus, right? By its minor plus 0. Right? The minor here would be 2, 1, 1 minus 1. The minor here will be 5, 1 minus 2 minus 1. So when you work this out, I got minus 2 minus 1. I got
Yes.
minus 5 plus 2. Face up now. So this is 3 plus 9. I got 12. Face up now. Right, so if you look here, right? This one here a little bit different. You have to find the determinant. You have to work on the determinant and say, well, here's what the answer is equal to 0. And then solve for x. So you go in the reverse. Right? You might get a quadratic or a cubic or something. Huh? Yeah,
What's your real use?
it don't matter. But because of the x plus 1, I might just go with the first one.
Why don't go in the class?
Yeah, you can do that. You can do that. I just don't want to multiply it too much. X and stuff. But the last was a good idea. Come on, bro. That's good. Right? So, What I got? One?
Yeah.
Which will you all use? First one? So we know the determinant is 0, right? So x plus 1 by 3, 4, x2 minus x by
I get one.
1, 4, 0. I'm now working it out.
I get
Alright. 1, 4, 0, 2. It should be a whole number.
I get x equal to 1 and x equal to -2.
But let's see. So this will be x plus 1 by
I put x into the quadratic. I mean x into the do I put x multiple quadratic?
so that's 6x minus 4x squared plus 1 plus 6 minus 4x minus 4x. So I got minus 4x squared minus 2x plus 2. Huh?
Minus 2x.
I'm missing something from here. Oh, sorry. Minus 4. I think that's what I'm doing my anyway, whatever. So that's a minus 8x, so this becomes minus.
Yeah.
And when you solve it, you got x to be and 1. Alright. Nice. So it's 1, right? All okay with that? Yeah. No, it don't matter. It could be 2. I didn't specify it.
Okay.
So it could be either one.
So, but what would be the determinant?
Question said the determinant is 0. These two lines need determinant. These 2 lines here mean determinant. You okay with that? Write one more and then I'm going to change it. Huh? And this one different. I cannot see it in my file. No, minus 4 lines.
Yeah, what's up? Yeah, what's up? That's so.
Alright, this one's the old year 2006. Huh? Nah, this one kind of easy. I know, fine, it. Try this now. Try this and then we do one last thing. You're done? So you have to show that the determinant is 0 for any value of A, B, and C. So pick a row, find the determinant, and see what happens. I have some rules to give you. Done. Architect. Alright, ready? So we just checking to see if we can see how to get a C. Right, choose the first row. Right, so that'll be 1 by, I don't know why.
There you go, yeah, that's good. Very close. You finished it?
right? B by A plus B minus C by C plus A. Right. Right, next will be minus A by 1 by A plus B minus 1 by C plus A plus B plus C by C minus B. Hopefully, this is simplified to something nice, right? Hopefully. So we'll get AB plus B squared minus C squared minus CA minus A by, we can multiply that one time, A squared minus AB plus AC minus A squared. And here, difference of two squares. Yeah, minus A by E. Oh, minus and minus, that should be plus. That's
So
yeah.
the power of press any key cancel.
Right? Can we do some canceling? Let's hope so. This will cancel. This looking like it want to cancel. This looking like it want to cancel. This looking like it want to cancel. This looking like it canceling, and we getting 0. So the determinant is always 0. That's okay? Everything cancel. Take these rules down. We have some rules whenever you're finding determinant, you have some rules to do. Huh? Yeah, that was 2006. Write it down. These are the rules for determinant. Rules when finding determinant. Number 1. Interchanging rows of columns. Interchanging rows of columns. Interchanging rows of columns. Like if you switch the first row to second row, yeah, fourth column. Interchanging rows of columns. What do you all sorry, sir? Interchanging rows of columns. What do you all think will happen? If I were to switch these two rows here, what do you all think will happen to your final value? Nothing? But remember the sign matrix is switching, so the sign will change. Right? The determinant changes sign only. Magnitude stays the same. The determinant changes sign only, magnitude stays the same. Right? So you'll get the same magnitude, it's just the signs will change. Next one. Multiplying a row of column by a constant. Multiplying a row of column by a constant. by a constant k. By a constant k. So stop. The determinant becomes k. The determinant becomes k by the original value. K by the original value. Right? So if you multiply a row by 3, the matrix will become, determinant will now become 3 by whatever the old determinant was. That's okay? What would happen if you multiply the whole matrix by 3? What would the new determinant become? You're multiplying the whole matrix by 3. You close it. No, 9. How many rows is that? 3. Okay, multiplying 3 by 3 by 3. Multiply 27. Right? So it becomes, so write this down. If we multiply the entire matrix by k, now, same one. If we multiply the entire matrix by k, if we multiply the entire matrix by k, the new determinant is k cubed by the whole determinant. K cubed, k to the power of 3 by
3 by 3.
yeah, this one 3 by 3. K cubed by the whole determinant and the whole matrix. It becomes k cubed.
If we multiply
The new determinant will be k cubed by the whole determinant. K cubed by the whole determinant. Next one. Next one. Adding a multiple of one row to another row. Adding a multiple of one row to another row. So stop, the determinant remains unchanged. That's why, like, when you're solving simultaneously, you gotta remember you can multiply a matrix, multiply a equation out and then add them and solve it. Remember that? Multiply equation 1 by 2 and then minus, so you get rid of x. Next one. Identical rows of columns gives a determinant of 0. Identical rows of columns gives a determinant of 0. Of course, if any row is 0, determinant is 0, right? If any row is all zeros, the determinant is 0. Same point, same point. Same point. If any row is all zeros, if any row is all zeros, then the determinant is 0. Last one, the teacher just get done. I'm going to take a still. For a triangular matrix, the determinant is the product of the diagonal. For a triangular matrix, the determinant is the product of the diagonal elements. For a triangular matrix, the determinant is the product of the diagonal elements. Right? I did not show you what is a triangular matrix. Right? It's very similar to something called symmetrical. Watch it here. If you look at this matrix, right? If you look at this matrix here, 1, 4, 5, 1, 4, 5, you recognize the row and the column is same thing. 2, 4, 2, 6, 4, 2, 6, same thing. 5, 6, 3, 5, 6, 3. This is a triangular matrix. So whenever this happens, the determinant is 1 by 2 by 3. That's okay? All right. Do I show you that one time?
Last
Nah, answer this now.
this one.
Answer this and then we'll see how things go happen.
So the other thing, I'm trying to
Yeah, I'll show you that later on again when we do transpose. Oh, you see that, right? Yeah, that please let me done. Last thing. Last thing I'm done. Last one. they get 5. Right, I mean, interested in 5. 2, what? After they get a 5. Right, for your hand, but
Yeah. I think some of it.
yeah. Guys, signal boy. Right, a million interested in A, B, and C. So hopefully you get 5, right? Everybody got 5? Yeah. So what will happen now? So write down the determinants of each of the new matrices. Matrix B is formed by interchanging row 1 and row 2, and then interchanging column 1 and column 2. What will happen? Remain the same? Let's see. It should remain the same. So you're switching. Which one first? Row 1 and row 2. You're switching row 1 and row 2, and then you're switching column 1 and column 2. Sorry. Switching column 1 and column 2.
They will change. And they will change.
I'm very confused with that now, eh?
They will change.
Interchange row 1 and row 2, and then interchange that column 1 and column 2.
It will change. The more it change the number. Yeah, but it changed because the question.
No, but change the sign. They change the rows, so the sign will change, right? Then they change columns of the sign that change. So the sign will change.
Yes. I apply.
Alright, we'll check it back, but I suspect they should stay fine.
That's it, I will change it.
They should stay fine. Whether we still have B and C.
No, but sir, I'm very confused.
B and C. What's the next one? Row 1 of matrix C is formed by adding row 2. Right? What will next one be? Row 1 of matrix C is adding 2 of them, so and the rows remain unchanged, right? So that will be same determinant. Right? Same determinant. Whenever you add in, it will change. Right? What about D? Matrix D is formed by multiplying each element in E by 5. By Q by Q. So to be 125 by 5. Right? Like 5 to the power of 4. 625, right? 625.
Yeah.
Are you okay with that? In the back, are you okay? Or you do my favor now. Just go over A now. Actually work out A for homework. So it's the row and the column and stuff. What you get? Yeah, I don't feel it. I feel it should be 5, but it's not looking like that. But try to go over and make sure you get positive
I
vibes.
promise I'll try forward. You see how the you see how the finish